All right. So, okay, does everyone have their piece of paper out?
Yes, sir.
Okay. What we're going to talk about today is two properties. And it's not ones that I can just give you the shortcuts right away. You've got to earn the right to get them. So this is your right, this is your earning your right, is writing this stuff down that we do today to make sure that it makes sense to you.
Is this a proof?
It's not a proof. We're just going to show you how they developed it, and it is challenging, so you need to write this down. Okay? Alright, so first, the section we're in. We're jumping to section 3.3. This is still doing differentiation.
Why are we doing all this paper instead of running notes?
Because I want to see it, and then you're going to be able to write the shortcut.
As if you can't
Your
see
normal
it in
notes.
our notes.
This is your way to get earn the right to earn the shortcut.
Oh.
What if I don't want the shortcut?
Then you can just do this long process every time. All right. So okay. First, what we're going to learn is the power rule for if you do a product. That's going to be our first one. This is the one that probably takes the longest, the product
I might
rule.
just return the watch.
That means multiplying.
Thank you.
So that's to multiply. And the second rule is if you do a quotient. Okay, in fact, let me put that. So this is the quotient rule.
I bet that means.
Do we have to write this part or just when you start actually doing math?
So just doing the math part.
Okay.
And quotient is when you divide. Now I'm going to show you the idea behind it. It's lengthy. You need to seriously pay attention to this. You can get lost in the first few seconds if you're not paying attention to it. No, put your hand up. All right. So first, these are the things we need to know. Number one, we need to be able to find area of a rectangle.
No.
So that's just number one. You got to
Base
know
times
that.
width.
Okay. What?
No, base times height.
Base times height, length times width. It's right over there, by the way.
Oh.
All right. So.
Thanks.
So if you have a rectangle, you take the length, you take the width, or switch them base and height, whatever you want to call it. You multiply those together, and that's area.
Physics.
So it's length times width.
No.
Okay, does that make sense?
Yeah.
Okay. Now the reason I'm bringing this up is that I'm going to give you the visual to help you with like how did they come up with this crazy thing.
You don't have to write that.
So no, this is just something you probably already know it.
I know.
Okay. All right. Second thing that we need to know is what is the default formula for if you find a first derivative. Just not like the whole big thing, but what is the default way of doing a derivative? Well, it's using a limit, right? That's like go-to version. That's what a lot of people always forget. Like, what's the default way of doing it? It's doing a limit as h goes to 0, and it's doing this. You're subtracting two different functions together, and you're always dividing by h. You should already have that. We've done that so many times in a row. Like that should just come second nature to you. Now, I know it was nice that we learned the power rule. That you could drop the power, you could do it like super quick, super short. You guys seem like you're really good at doing that.
Yeah.
The problem is, when we go to the product rule, it's different. It's a completely different animal. And so you need to see like where it comes from, like how did they even come up with this like crazy thing that just works every time? Because the shortcut is simple, but knowing how did they even start, like how did that even come about, is from what I'm about to show you. But it requires this stuff. Now, the other thing is, the other part before I get started here is knowing what this means. This is a symbol I'm going to use today. It's just going to represent, like delta F means change of F means this. That you're subtracting this.
What
You're
was that?
subtracting that. You're finding the difference in the functions. That's all it means. So it's like the top. So I could have wrote this, I could write this thing right here, what you're looking at. I can write it like this.
There's no numbers on the board.
Oh.
Okay, so that's just a shortcut for writing it. The delta of F is the change in F as we went from like 1x plus h to the x. It's the difference in them.
Can you tell me when I'm supposed to start writing?
Yes. Okay, these are the three parts that you need to kind of know before we get started. Because I'm going to use like little notation. I'll talk about area a little bit. I'll draw a picture so that you get a kind of a visual aid. But the people get lost in this one because this is how I learned it. They get lost in just the little pieces like, oh my god, yeah, I forgot how to find area. Or I had no idea what the little triangle thing meant. Like, that was something that you probably may have seen like way back in algebra days, like delta y over delta x, where it's a change like for defined slope. But it was like one of those things, I just needed to see it and go, okay, I understand what that means. All right, we ready to go? Okay, here's the part I'd like you to write down. Number one, I'd like you to draw a rectangle. just draw a default rectangle. One of the walls, we're gonna call this wall f of x, and this wall is g of x.
How big?
A decent size where we can draw it. We're gonna draw around it too. But we're gonna put a bunch of,
Something like this.
we're gonna put a bunch of
It's
math.
almost
So
exactly.
we're gonna add a little piece up, we're gonna add a little piece to the side. But most of the math's gonna be down below. This is totally fine. Like, that's fine.
I can't
Is this,
see that.
but was this good?
Good. Okay, let's make
I don't
sure.
wanna draw
everyone's
too
got
big,
it.
Doesn't
we're
work,
gonna
does
do
it?
a lot of
Yeah, that's your
stuff.
fine.
Come here, let me
Because well, for you, you
Yours
might have
is
to add down.
okay.
We're fine. Okay, question?
just see if mine is good. Also,
Yes.
happy birthday.
No, I'm good.
Alright,
You
so-
have to accept my
okay.
birthday.
This is like 40 of them.
Now, why I'm giving you this, this can be a big part of what we're gonna be finding today. The goal is to understand that our function is like what we're trying to find the first derivative. I'm gonna call this m, just because I just need to make up some default thing. We're trying to figure out, bless you. We're trying to figure out when you multiply these two functions together.
I've ever.
Okay, bless you. Alright, when you multiply these two functions together, like f times g, what is that on that picture?
And
The
Yeah,
area.
it's m, it's area. Okay, so what you're actually doing here, this is representing area. That's literally what it is telling you.
is it actually x or did you just make the m up?
I just made that letter m up. Now, these are my two functions I'm multiplying together. Now, what we're trying to find, the whole goal of what we're trying to learn today is what is the first derivative of it? When you have two things like two crazy polynomials, anything multiplied together, there is a shortcut for doing it, but you have to understand that they're multiplying these two things together, and what I'm trying to show you is like what is the shortcut we can put here. That's what we're trying to learn today. Not this like
So we have to earn-
huge, you have to earn the shortcut today. So, to get to this part, you have to understand what we're doing. We're multiplying two things together. Does that make sense? And that's like the overall function. That I'm calling it m. All right. So to do this, to find the first derivative of m,
I wish you would have been.
okay? To find the first derivative of m,
Not m.
here's what we're doing. I'm gonna write this default thing down. To find the first derivative of m, we're doing the limit as h approaches 0, and
Wait, this.
the two functions I'm multiplying together are these. It's going to be x plus h plugged into the f function. It's going to be the g with the x plus h plugged in, right? It's the normal thing we do. We plug in x plus h's, right? Because again, this is my overall function. This is the one I'm dealing with. I'm trying to find the first derivative of this monster. And what do we have to put in the back?
What is that?
17.
Yeah, we have to subtract, not 17. We have to subtract these two things, multiply together. We're subtracting what the original function was. My original function I gave you, m of x, was f of x times g of x. Does that make sense? So we're subtracting whatever the original thing was. I have no idea what it turned out to be.
Over
But that's
h?
it. And then it's all over h. Okay, does that make sense what we're doing?
Yep.
Yes.
Okay, now, the whole rest of this problem is learning how to take out that crazy amount of stuff that's written there that's ugly looking and substitute little things in there that make the shorthand shorter, like so we can make this thing like look a little bit easier to look at, and then we can get to the shortcut, which is really short and simple and sweet. Okay, that's what we're doing. But it required that you know all those like setups that we talked about earlier. Okay?
It's just gonna be a lot of letters.
Yeah, just a lot of like terms and stuff. All right, so does everyone have like what we're trying to figure out?
Wait,
I don't want to do that. That takes too long.
Okay.
We're trying to learn the shortcut.
No, it's gonna take us that.
Okay, so here's the idea.
Write it down.
What we're gonna do, we're gonna expand this wall further, going up. So we're just gonna take this wall, extend it up. That extension we're gonna call delta f.
You wanna go
That's
over?
the change in f. It's like plus h.
You wanna go over?
Okay, and we're gonna go over as well.
Thank you.
Okay? So we're adding a little bit on to the top. We're gonna add a little bit on to the side as well.
Wait, what?
So we're gonna go this direction a little bit.
G,
Why
bro.
did you
Yeah,
tell me this?
and so this is the change in g. Now, you could call that like plus h. I just called it change in g. It's like, it's a little extra.
Why do
piece.
you call it that?
Because that's the shortest way to talk about it. It's like the change in g. There's a little bit of difference.
Oh, no,
So I'm extending this wall just a little bit further. Okay, now, do you agree that it's changing my area? As I extend it, the area's bigger, okay? And now there is this overlap up here, this part up here.
Oh,
That's where these two things interact.
do we
okay.
want that to be filled in?
Yeah, so just put that little box up there, because I want to make this an
What?
entire rectangle. So you gotta fill in that little box up in that corner.
Just for the heck of it?
Yeah, just, cause I wanna make a big rectangle. I still wanna keep this like perfectly square, 90 degrees in the corners. I don't wanna have weird stuff going on. Okay,
5.
the goal here is to show you what that is giving you, okay? So, here's the idea. The whole, so this is very generic and you can talk about this. The whole function, you know, when I want to find that first derivative, right? The first derivative is finding the difference in the entire picture, subtracting, and I'm going to highlight this. I'm going to put little lines in here. So I'm highlighting the original blue box. It's easy for me to see it because I have it in a different color than what you have. Just highlight the original box. Now, I like what Jane did. She just like made her original box really dark and everything else was really light. That's easy to see. Okay? So, what we're doing when we find the first derivative, you're taking the big picture, the big rectangle, and we're going to subtract the original rectangle.
Wait, are we writing this down? Big rectangle minus.
Yes. Yes, write that down. So this is gonna be like a shorthand for like.
Do we want to put limit as h approaches 0?
Yeah, so we're gonna eventually throw that in there. So
Okay.
does everyone understand? Like I'm subtracting. Like that's what this stuff is up here, and I'll show you on the picture what they're talking about. And we're still finding the limit as h approaches 0. And what has to go on the bottom?
7.
H.
H. You still have to divide by h, right? It's still the generic thing. I'm trying to give you like the most generic way to explain it to you, so that it hopefully makes sense to you. Okay, because the big rectangle, the hardest part about seeing this is how do they figure out the big rectangle? It's doing this. Let me put it in a different color. This wall here
Yes, Mr. O.
is g of x plus h. And again, why is g of x plus h? This is like, this term here is like the extra h they're adding on. It's the change in the g function. So that whole wall is x plus h. What is this wall then?
X plus.
Yeah, it's adding that little extra h on, because that's what this little delta f means. It means that change, I added a little bit extra. And that's why they're coming up with this. That's why when they multiply the length and width, they're still finding the area of the big rectangle, and they're subtracting the area of the original rectangle. That's how I'm looking at this picture. That's the best way I've learned it. Now, when you subtract those on the top, when you actually take, so I'm going to put this off to the side. When you actually take the big rectangle and you subtract the small rectangle. So if you were to actually do this,
You
like,
straight original.
You should write default rectangle.
Good point. Original rectangle. Thank you.
Yes.
Yeah, I don't want to confuse you. All right, I'm trying to keep this as easy as possible. So,
Same
Wait,
terminology.
Okay.
rewrite this again.
so I'm just showing you what this is. Okay, when you actually subtract these, do you agree that when I take the big picture
You
and I
get all the
subtract
plus
this,
H's.
I'm left with this stuff?
I suppose I could agree to that.
Yeah, that's what's left when you take the big minus that's the pool, basically.
The pool.
So
Oh,
now,
Why did this?
do you want me to put plus H's in there?
Yeah.
yeah, it'd be a smart idea, so you kind of know where the plus h came from.
Wait, but what if my change it?
Just put it next to it. Oh, that's fine.
Oh, plus H's.
All right.
Oh.
All right. So now, what these little boxes are? What's left when I actually take the big area minus this original blue triangle or blue rectangle
I
from
thought
me?
that was the.
I'm left with the areas of these little rectangles. The areas of these things. How I find them? The area. I'm going to start with this piece right here. This piece I've highlighted. The area of this piece is delta f times g of x. Because this, this distance right here is g of x, right? Do you agree? And when you take g of x and you take it times h, or times, I should say, f of delta of f, I get this little area right here. So, I'm going to be with delta f times g of x. And I'm going to need to add that to this piece over here. In fact, I'll use a different color. I'll try to color code it the best I can. This little box. That box, that little area, that little square that's in that corner, is delta f and delta g multiplied together. That's that little area. It's like the h times h basically. But it's delta f times delta G. That's that little box in that corner. That's the area of that little piece. When I multiply those two numbers together.
Plus tangent
Plus
G
delta
times.
G.
Plus, yeah, plus delta G, so now I'm gonna color for this. Delta G times f of x. So, delta G times f of x.
It is.
Oh, good. I couldn't get any more on my mind.
Okay, are we all in like a slight agreement on what we're doing here?
Yep. Yeah.
Alright. I just don't wanna lose
That
anybody
part
yet.
kinda lost me.
I just don't get why there's no numbers.
I don't wanna do numbers yet, because numbers will throw in a whole new
Oh, yeah.
complex. We are gonna, I'll eventually show you the shortcut and then we'll just do numbers with it. so you
Oh,
can see
okay.
it. Okay, this is just to show you where it came up with it, because there's a way harder explanation than this, I'm trying to keep it easy.
Thank you,
Alright.
Mr. Ward.
So now,
Mr. Ward, you're doing good work. Would you like a ticket?
You learned it though.
now hold on. Now, what we're doing here, the next step is that all that stuff, when you actually subtract these pieces, those things are gonna go on the top, right here. So where I'm subtracting the original rectangle and the big rectangle, that stuff will go into those locations,
And then we divide by H.
okay? And then then we have to divide everything by
Are we going to
H.
plug in
Okay.
delta F?
Yeah, so we'll
Yeah.
talk about what delta F is and all that good stuff. Because we talked about what delta F is earlier. It's the change in F's and all that. So I want to show that, okay? All right. So let's put all of this stuff on the top, agreed? Okay, so I'm just gonna go to this one so you can see. Can I get rid of this big rectangle minus the original?
Why not?
So I'm gonna get rid of this, and I'm gonna put in what we just said is the big minus the original, and it's this stuff. I'm gonna put it right there over the H. So that is delta F times G of X plus delta F times delta G, that's delta,
Ooh.
change in G, plus delta G times F of X. Okay. All right.
How much did that roll cost?
And this is all over H.
2,000 tickets.
Don't try to do it.
This is all over
What's
H.
1/6?
Now, here's the part that will be tricky. I'll let you copy that down. I'm gonna substitute, because I think Darcy even said it earlier, I'm gonna substitute in what delta of F actually meant. Okay? We talked about it earlier, it was one of the first things we discussed. I said that was one of the parts you didn't have to write down, is like, what does delta F actually mean? It's the difference, it's the change in F's. What does delta G means? It's the change in G's. I'm gonna substitute those in. The only one I'm not gonna do that for is right here, and I can explain, okay? So in fact, maybe I should explain before I don't substitute it in. Do you agree that this is a limit?
I do agree.
Wait, I was gonna say maybe you just explain after, but yeah.
Okay, alright, so do you agree that this is a limit?
Yes.
Limits, we have certain properties about limits we talked about the last chapter.
Addition.
So, Tyler, turn around. So, the idea is that if you take a limit, you can separate the limit over all the parts. As long as they're being added together, like these three chunks being added together, I can separate the limit into each one separately by themselves. So in fact, I'm gonna do that, and this is the part I was gonna wait a little bit, but maybe this will be easier to look at. So, I can separate these. So, here we go. So the limit, as h approaches 0, limit as h approaches 0 of delta f times g of x over h, like that part by itself,
Yeah.
plus,
I don't have to write this down, right?
this is the part you should probably write down.
What?
H
Whoa, whoa,
over 0,
Wait, do you have to rewrite limit every time?
yeah, because we're doing 3 different limits.
Wait, why don't I have to write this part down?
Because this is gonna get me to my shortcut.
Okay.
Okay.
Mr. Ward, you're a genius.
Delta f
Mr. Ward, did you
delta
invent
g
this?
over h plus limit
Yeah.
as h,
You deserve so many tickets.
What?
h is 0, delta g times f of x. Okay. So, oh, that's over h. Alright,
I take you.
Yeah, hang on.
Thank you.
that's fine, we're good.
Oh, you're welcome.
Not you.
Didn't know we'd have to take the paper for
Mr. Ward,
Yeah, that's, like, that's why I gave you a separate sheet of paper.
do
What?
you not want to participate in my ticket?
You asked me about those tickets again, I throw them. No joke.
Across the room.
So, now,
You like whisper through that.
now, where we're at. This part right here,
Ask you what you
this
want.
this piece where we're dividing by h's. The h, when you have a multiplication problem, you have to put the h under one of these, but when it's like the same situation here, the h would go under one of them, if that makes sense. Because it's not like adding. Adding, you can separate the h's like I did. Bing, 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 3 h's.
Bing.
But when they're multiplied together, this is a rule of multiplication and division, when you have items on the top that are multiplied together, the h only goes to one of them. Does that make sense? Like, you have to
Yeah.
pick one that it goes to. So
Does
the
it have to
idea
be
is
a
that,
change of something, or can it be the G of X?
it can be g of x.
Oh.
I'm just putting.
I thought you were making it sound like
No,
a change of something.
No, so, alright, so limit h approaches 0 of the delta of f, I'm gonna put that over h times g of x.
Wait, do we do this too?
Okay, what?
Do we do this too?
Yeah, this is a part, these are the individual pieces, I'm talking about individual
Are you gonna
chunks.
choose a F or G for
So.
the next one?
The next one, I need to put the h under the f function, okay?
Yeah,
So in fact, I'm gonna move this over just so you can see this, sorry. It's the same thing, I'm gonna rewrite it, I just need to make it smaller. So delta f with the h on the bottom times g of x, okay? Plus the limit as h approaches 0, I'm gonna put the h underneath the delta of f,
Didn't we already do that?
and then this is time
Yep.
delta g,
This is the time.
Oh geez, this is so much for my head to wrap around.
g, plus, and now I'm trying to make it easy. H approaches 0 of delta g over h times f of x. Okay.
Okay.
How did you get the H away from those second
You just pick one.
Because if these are being multiplied together, you have to pick the h go under one of them. If they're being added, they go to both. That's the rule of addition. It's like when you add two numbers together, right? When you add like, I don't even want to write this because it's just going to mess up people. When you add fractions together, you only add the numerators, but you add the numerators and the h was literally from both of them. But when you multiply it, it only goes under one of them. I don't even want to write on the board. I'll mess up like
Yeah,
5
don't do
people.
it.
They won't.
I'll give it
What
a
five
shot.
people would we need?
Would you get a different answer if you put the H with all the other sides?
No, it just won't simplify as clean. It won't simplify as clean. All right,
How do you know?
just the way it looks. Just the way it looks.
to.
So, all right. Now, hey,
Yes.
okay. So, what we have here, we have a bunch of products. Okay, a bunch of products of all these items. What I'd like to put here in this middle term, I'm gonna multiply this. Now I know this is weird. You can do this. I'm gonna multiply by the number 1. Will that change that middle part? No, because multiplying by 1. But instead of 1, I'm gonna make this times h over h. Do you agree that h divided by h is 1? Yeah, so I'm multiplying by 1. The reason why you're about to see that when I find the limit of things, especially when h approaches 0, so the limit as, and this part, I just want you to watch this for a second. As h approaches 0, I'm gonna eventually figure out, f of x over h, and g of x, or g over h, and then this, yeah, so this times h. So when I'm evaluating the limit, as these goes to 0, these are the derivatives, because that's the difference. I'll explain this here in a second. These are the derivatives. But when this turns out to be 0, what's 0 times all of this?
Zero.
Goes back.
0. So that's why I'm doing this, is because these are the derivatives of their respective things. Like that's the derivative of f, that's the derivative of h or g. And what you're going to do is when h is going to 0, this h will turn out to be 0 times all of this. So what happens to this thing?
We just
Cancels out.
Cancels out. So the middle is gone as h approaches 0. Because if I actually did what I had here, this will actually turn out to be 0 times all these other derivatives, and that middle part goes away. That is the hardest part for people to see unless you understand how derivatives work. That when you take a derivative of a number, it turns out to be 0, and you're going all the way across and multiplying it.
If
So-
you plug in 0 anywhere, then it's always gonna be 0.
Yeah, so for this, but here's the problem. On these other ones, I don't just have an H outside. The H is on the bottom. Like that one had an
You
H on like
divide
the
by
side
0,
that I was
it's gonna be
multiplying.
0.
These don't have H's in the back. This one doesn't have an H in the
Or
back.
you could add one just like you had to.
I could, but it won't cancel out like the last ones would.
Oh.
Because the way that there's deltas, watch what happens here. What we talked about earlier,
That's what you did with that.
what I talked about earlier was this part. This thing is, this delta of f is f of x plus h minus f of x. That's what the difference in f's are. And this is over
You
h
wrote that. I
times
wrote it down earlier.
g of x, right? This is the first part we talked about, that the difference in f's is this. And what you're looking at here, and this is getting down to my, this is getting down to my shortcut as h approaches 0.
Like the long one.
This part right here, when you look at that, what it's written, that's a derivative.
Where'd that come from?
Really?
That is substituting this thing out. Because if you look at back at the very first line that you did, because tomorrow I know that you have that first part written down, deltas of f's, the change in f's, is literally f of x plus h minus f of x.
Yeah.
That's where it
You
comes
just
from.
plug that into
So
the-
all I did was substitute this thing out for what I said in the very first line today. This is a derivative. It is literally, this thing, what you see written here is f prime of x, like old school f prime, times g of x.
Old school.
Do you see that now? Do you actually see that?
Yes.
Okay, this thing is gone. This is literally 0 in the middle.
So the H that you had, you know how you had like the change of f over h
Yes.
times change of g over h?
Yes.
Is the h that you put beside those the one that was on top of the g?
Yeah.
You get what I'm- Okay,
Yeah.
that's what I was.
Yeah, that's the same age.
I'm really glad
Yeah.
you got what I was asking there.
Yeah, yeah. Now, right here, if I plug this in, if I plug in the change of g's, this is g of x plus h minus g of x all over h. That's this part that I just substituted in
Yes.
Thank you.
times f of x, right? Because that's f of x in the back.
Just try.
And this thing, what you're looking at right here, is g prime of x. It's the first derivative of g. That's like the old school way of writing it.
Yeah, let's try.
Times f of x. This part is what I want you to write down. This.
You don't want us to write down the middle.
If like you didn't get this part written down, fine. You better have that written down because what you're looking at right now is the shortcut.
Shortcut.
It's the shortcut. This is the first derivative of m of x.
Where'd that 0 go?
The 0 goes away when you add 0 to anything. It's called an additive identity, so I added 0. This is the
0 go?
We would have had a lot more time to learn if you just would have given us this at the beginning of class.
No, I said you had to earn it. So if you didn't write it down, you can't use that, and you have to do all that other stuff I just did from now on.
Yeah.
What if I memorized it? That
Nope,
where
if you don't have it on paper, you have to do that from now on.
But you can't stop me.
I can't, I'll count it wrong.
That's not fair though. This is the right answer.
You had to earn the right to get the shortcut today.
Well, don't erase
Did you earn it, Nielsen?
Yes.
Oh, did he
I haven't
actually
indeed
not
earned
write
it.
it though?
Nope.
I have.
That, you really,
Are you gonna look at everyone's paper?
you really done it there.
Yeah, Mr. Ward, would you like my paper?
You have it written down?
No.
I guess that's for you to find out.
Dude, you're just pushing buttons.
Okay.
Do we have to have the F thing?
That was just the original function.
Okay.
That was what I started with in the very first line today.
Okay.
Like, we're finding the first derivative of my original function.
I give you 5.
Alright, that's what you're looking at.
I don't get the shortcut.
I don't.
The short, okay,
Literally-
let's explain what
Yeah, I
this
don't
is.
know why it's considered
Okay.
a derivative.
Alright.
You want mine?
Yes.
Okay, now, I had a good question, like, what is the shortcut? I'll show you how short it is.
Alright.
We'll do it for an actual
We haven't
premise.
done it yet, have
Yep, we haven't done it yet. But I just showed you the formula work here.
Yeah, I was kind of confused when you did all that work and you said, this is the shortcut. I was like,
Okay.
No,
Hey,
you mean,
I'm getting rid of this here in a second.
you don't mean this is the shortcut, you mean this is the answer we
Take a
should
minute.
get. That's for you, you wrote down everything. What do you mean, that's the answer we should get? Just kidding.
Because if all fails, you would have had to do the whole limit thing every single time like what I did.
500% profit.
Oh,
for 10 tickets.
oh, okay, I get what you're
No.
talking about now.
Yeah,
I
this
was
is
so
the
confused.
formula.
Okay,
Now,
yes, okay.
now that I know that this is what it means, I can now do that little power rule that you guys have been doing so much, and you're really good at.
What you need.
Yes, it
That's my shortcut. Alright, hey, here we go. Let's do an example.
I'll skip it. No, you can't skip it.
Do you want me to pull my paper over here?
All right, here we go.
Can I have a different
paper?
I avoid those.
I don't like
Just
how it
pop it.
plays through. I don't like how it plays through. Thank you.
Alright, okay, here's my shortcut today. So f of x, let's call this 4x minus 10. Now let's call g of x